I'm Justine Sarcauga, and today I'm here with my groupmate, Francheska Recierdo. And we are excited to share with you our approach to solving a problem using a technique called dynamic programming. Now you might be wondering what is exactly dynamic programming meaning is. Dynamic programming, or DP for short, is a powerful method used to solve problems by breaking them down to smaller, simpler sub-problems. So the key idea is that instead of solving the same sub-problems multiple times, we store the result of those sub-problems and reuse them to build up the solution more efficiently. This saves a lot of time and makes the process much faster, especially when dealing with complex sub-problems. So, what problem are we solving today? So, we are going to demonstrate how dynamic programming can help us with the knapsack problem. In this problem, we have a list of songs with different durations and endorphin values. So, our goal is to pick a set of songs that gives us the maximum endorphin value while staying within a given time limit. And now here's the code that we use to solve this problem. So we've implemented the dynamic programming to efficiently find the best combination of songs within the time constraint. So now let me explain briefly each part of the code. So in the knapsack function, in initialize DP matrix, we create a to-do list, or DP, where each cell will store the maximum endorphins achievable for a certain number of songs and a given time limit. And in the loop through songs, so for each song we check every possible time limit, or the W, and decided whether to include or exclude the songs based on its duration and endorphin value. So if the song's duration fits within the time limit, we calculate the best option between including or excluding the song. And if it doesn't fit, we simply carry over the value from the previous row. So the result is, after running this function, we get a DP matrix that helps us find the maximum endorphins for any given time limit and a song combination. So next is the total underscore endorphins open and closing parenthesis function. So this function calculates the total endorphins for a user selected list of songs. We loop through the selected songs and check if each song fits within the remaining time, and add its endorphin value to the total if it fits. So the remaining time is updated as we select the songs. And the result on this is the function returns the total endorphins value for the selected songs based on the time constraints and the selected songs durations and endorphin values. And here is the code part of the code for the main program flow. So in the song list, a list of songs, and each represented by a tuple with duration and endorphin value. So in user input, the user is asked to enter a time duration, which represents how much time they have to listen to songs. Next is the call, or the knapsack. The function calculates the DP matrix based on the user's time limit. So next, the display, or the DP matrix. So the program prints the DP matrix showing the best possible endorphin values for different time limits. And lastly, the user song selection. So the user is asked to choose songs by entering their numbers, and the program calculates the total endorphins based on their selection and the DP matrix. So the result is the program displays the DP matrix showing the best options for different durations, and after the user selects their songs, it calculates and displays the total endorphins for those selected songs.
Good day everyone, my name is Francheska Recierdo, and I am the one who will explain to you how this code works. But before we dive into that, here's the formula of how we come up solving these examples. So, here's the formula na gagamitin natin to solve each rows. So, we have the I and on this part naman, we have our J. And over here, we have the items from 0 to 10. And dito naman ang length and our endorphin level. So, ang length natin will represent as the weight while the endorphin level naman will represent as the value. So, as you can see here on the formula. Now, let's start. The first formula or rule here in 0, 1 sa dynamic programming is if I or J is equal to 0, then dpij is equals to 0. So, we're just going to initialize it since yun yung sabi sa rule natin. And on the first formula, so once na ma-initialize natin ang column na to, we will come up na sa susunod na column, which is the column 500. Now, let's proceed first to our second rule, which is on the second formula. Ang sabi daw dito, if length I minus 1 is greater than J, then dpij is equals to dp minus 1j. So, di ba, yung length natin is 500. So, the question is, mas malaki ba ang length natin sa J natin, which is 500 also? Di ba? Hindi. So, magpo-proceed tayo on the third formula. Else, the third formula is this. Else dpij equals max dp I minus 1 j dp I minus 1 j dp I minus 1 j minus length I minus 1 plus endorphin I. So, here po, ilalagay natin always is yung max. Dito, the dp I minus 1, sabi sa formula. So, ilalagay natin yung I natin, which is 1. So, magiging 1 minus 1. Then, yung J natin is 500. Tapos, ganun din sa pangalawa. Yun din ang ginawa natin. Ilalagay din natin yung I natin, which is 1. So, 1 minus 1. And, yung J natin, which is 500. Then, minus sa length natin, which is 500 also. Tapos, plus natin yung endorphin level, which is 510. So, yun lang din. 1 minus 1, 0. Then, bring down 500. Ganun din. Ganun din dito. 1 minus 1, 0. 500 minus 500 is 0. Then, plus 500. So, 0, 0, plus 500. So, yun nga. Sabi ko kanina, ilalagay natin yung max, yung pinakamalaki. So, dito ang max natin is 500. So, yan ang ilalagay natin. Next is row 1, column 1,000. Here po, disregard na natin yung dalawang formula. Focus na lang tayo sa third formula to make it short. So, yun, ganun din ang gagawin natin. Ilalagay lang natin yung I, which is 1, since nasa 1 pa lang naman tayo. So, 1 minus 1 is 0, then bring down 1,000. Ganun din. 1,000 minus 500 is 500, and plus natin yung endorphin level, which is 500. So, 0, 0 plus 500. So, ganun pa din. Always ilalagay natin kung ano yung mas malaki. Kung ano yung max. So, ang max natin dito is 500. Kaya, yun din ang ilalagay natin ulit dito. So, when you repeat it using the formula, and since it is not big or big sa row natin or sa I natin, ganito ang magiging kalalabasan niya. Basta yun lang, we will just follow the formula and everything will fall into places. Now, let's proceed na sa po, skip na natin ang first rule since hindi naman siya 0. Sa second rule naman, hindi din, kaya proceed na tayo agad sa third step. Now, let's solve it. Ilalagay natin yung I, ganun pa din. So, dito ang I natin is 2, kaya 2 minus 1. Then, yung 500. So, 2 minus 1 is 1. Then, bring down 500. Ganun din sa kabila. 2 minus 1. 1. Dito, 500 minus 300 is 200. So, since wala naman tayong value na 200, so, kung ano or kung saan na lang siya malapit. So, yun, kung saan siya malapit, yun na lang ang ilalagay natin. So, since ang 200 is mas malapit siya sa 0 kaysa sa 500, ilalagay natin is 0. Ayan, as you can see, ang matrix natin is 500, kaya 500 ang ilalagay natin. Next naman is the row 2 column 1000. Ganun pa din ang gagawin. Skip na natin ang first 2 formula. Proceed na agad sa pangatlong formula. As I've said a while ago, we will just follow it. So, ganito siya. Lalagay din natin ulit yung I natin, which is 2. Then, minus 1. Tapos, ilalagay natin yung 1,000. So, 2 minus 1 is 500. Then, dito naman sa kabila, 2 minus 1 is 1. Then, ganun din sa kabila. Dito, 1,000 minus 300 is 700. Tapos, ayan. So, yung mataas is 600. So, 600 ang ilalagay natin. So, ganun lang din yung mga susunod. Kaya, ipagpatuloy lang. And ito ang magiging outcome niya. So, that's it po. Ito ang kalalabasan ng song matrix. And that's how it works po. Thank you.